A very good morning all. Today we are discussing our new exercise of chapter number 9, that is B, named as ammonia. And in this ammonia, its formula is NH3. If we talk about its molecular mass, that what is the mass number of ammonia, that is 17. As nitrogen contains a mass of 14, that hydrogen contains a mass of 1, then 14 plus 1 into 3, because we have 3 hydrogen atoms, the total mass comes out to be 17. And if we talk about its structure, that is 1 nitrogen, hydrogen, this is hydrogen, 1 lone pair is there. If we talk about its orbital structure, then we have hydrogen, hydrogen. This hydrogen is sharing electrons with nitrogen to complete its duplet, and the same along with that, this nitrogen is sharing all the electrons with the 3 hydrogens to complete their octet. So we have here this lone pair of electron, that the lone pair is present, and we have here the covalent bonds are also present, that the covalent bonds are also present along with them. So these are the states, and these are the general little introduction about the ammonia. The next is where the ammonia molecules are present. So they can be present in the free state. In the free state, they are present in water as well as they are present in our air. But whenever we are talking about their combined state, that in the combined state where they present, they may be present with ammonium chloride, they may be present with the ammonium sulfate solution, and they can also be present along with your urea. That is the formula of urea, NH2CONH2. They can be present with the urea also. So that is the combined state present, all of them. Whenever we are passing through a decaying heap, that means I am talking about a decaying heap, then a pungent smell is coming out from that heap, and that pungent smell is due to the bacterial decomposition of your urea. That bacterial decomposition of urea, and whenever the bacterial decomposition of urea will occur, then it may produce you that ammonia gas, and that ammonium gas is very pungent in its smelling, right? That ammonium gas providing is a very pungent smell, and that smell that directly attacks on your nostrils. Okay, that is a very pungent and sharp smell is there, and that smell attacking your nostrils very fast, so you can easily detect its smell, that the smell is there. And if we talk about the forms of ammonia, ammonia can maybe present in the gaseous form, that it may present in the gaseous form, or secondly it may present in its liquid form. So that forms we are discussed further. Okay, that it may be present in the gas or liquid. That is a little introduction of ammonia. Now let's moving on its laboratory preparation. That is the most important part, and that is the including part of our syllabus. Let's go on to the let's move on to its laboratory. So in the laboratory preparation of ammonia, very first method is with the help of ammonium chloride. So the reactants used are, because when we are less learning your laboratory preparations or any of the reactions, you need to learn it through what are the reactants you are using. Okay, what is your reaction part, the drying agents, about its procedure, about its precautions. So everything you need to learn about them. The very first thing is about the reactants. The first reactant is ammonium chloride. Second reactant is your calcium hydroxide, which is also named as your slaked lime. That is given as your slaked lime also. That is the common name for the calcium hydroxide. And the second thing is about its reaction, that what is the reaction including in the formation of ammonia in its procedure. So that is included is 2 ammonium chloride when reacting with 1 calcium hydroxide molecule, that there is a formation of 1 calcium chloride along with 2 molecules of water and along with 2 molecules of ammonia are there. So whenever there is a reaction between two ammonium chloride molecules along with your one calcium hydroxide, formation of a salt, that is calcium chloride, along with two water molecules and two ammonia molecules are there, and we require these two ammonia molecules only in that reaction part. And what is the procedure we are using for the formation of your compound? So the procedure used is just nothing. We have a round bottom flask, and that round bottom flask is slanted. Round bottom flask is just slanted and heated up along with containing ammonium chloride plus CaOH twice inside a beaker, and just simply we are getting out our ammonia through that reaction. The reaction takes place, above reaction is taking place between the two molecules, and that the water molecules are releasing out from them. So that ammonia molecule produced is just collected over, but just passing out from a drying agent. The drying agent used here is your calcium oxide, that is the quicklime. The rest of other drying agents cannot be used here. Why the rest of the other drying agents cannot be used here? Because ammonia being basic in nature, if we talk about this ammonia, it is a compound that is basic in nature, and that basic, due to that basic nature, when ammonia is getting combined with your H2SO4, that is a drying agent present, then there is the formation of ammonium salt, that is ammonium sulfate formation of ammonium sulfate will occur. Let's talk about this ammonia. If reacting with the another reagent, that is P2O5, then also there is a reaction between these two molecules and the formation of ammonium phosphate will occur. Formation of ammonium phosphate will occur. So that is also not possible to prepare your ammonia, to dry your ammonia with the help of these agent. And the third one is, if we are using calcium chloride as a drying agent, then also this ammonia is reacting with the calcium chloride, and the formation of your addition product, that is CaCl2.4NH3 will be coming there. So we cannot use such drying agents H2SO4, P2O5 and CaCl2. So the only drying agent used is calcium oxide, that is your quicklime for the dryness of the ammonia, right? Okay, remember this thing. Now the next thing is about this diagram, about the procedure. So we are taking ammonium chloride as well as slaked lime. Slaked lime is your calcium hydroxide we are taking in this round bottom flask. That round bottom flask is slanted, just a slanted flask we are taking and providing its heat. Whenever the heat is provided to it, the reaction is between these molecules is that ammonium chloride along with this calcium hydroxide, there is a formation of your ammonia molecule plus water molecule and plus CO2 gas is also released out. Right, these gases are also releasing out. That is not the that is not the CO2, that is your calcium chloride is also releasing out, right? That ammonia gas is just passing through this tube and just enter into this chamber. After entering this into the chamber, it is collecting, because the gas is collected this in inverted jar, and the downward displacement of air, because that gas is lighter than air. If that gas is lighter than air, it means it will cause upwards. So upward, that is going on the upward side, and upward side we can collect it over from this part. So the upward portion, there is a ammonia gas, because this ammonia is, we know that, lighter than air. Okay, that is lighter than air, so we can collect it on the upward portion, because that ammonia goes upwards and the air goes downwards. So that it will showing the downward displacement of air. The air goes downwards from that, right? And you know what, why this round bottom flask is kept into the slanted position? That round bottom flask is kept into the slanted position because that water molecules form, that the water molecules are formed from this reaction cannot be present in this flask only, because the flask is continuously heating, and if the molecules are present in this flask, then there is a certain break, or there is a certain trickleness of that come back to the flask. So we are not required for that. We are not requiring any water molecules included into this flask. So that's why it is slanted, so that all the water goes to be collected over there, or all the water molecules going this into the slanted jar only. Clear this thing? So that is the first preparation. That is the first preparation for the preparation of your ammonia through with the help of ammonium chloride as well as with the help of your calcium hydroxide molecule. Let's moving on to the next part. In this process, that this ammonia molecule is not collected over the water molecule. Why? Because it is highly soluble in water molecule, and that CaOH twice. Why this base is used, this alkali is used? Because that is a cheap one, that can be easily used one, and that not a deliquescent like the other alkalis. The other alkalis are also there, that is the NaOH and the KOH are also there, but the rest of the other alkalis are deliquescent. So that CaOH twice is a cheap one material and not the deliquescent one. Then it's talking about at the place of that ammonium chloride, why we cannot use this ammonium nitrate and ammonium nitrite, right? We cannot use these materials also, because on heating this ammonium nitrate molecule, it produced you N2O and water molecule, not the ammonia. Here ammonia is not formed and we require the reaction for ammonia, right? And if we are using this ammonium nitrite, then also heating this ammonium nitrite, a nitrogen gas and water molecules are released, not the ammonia. But if the ammonia is not produced in these reactions, then how can we use them for the preparation of ammonia? That's why they are not using for the preparation of ammonia. Next is preparation of aqueous ammonia, AQ ammonia, that is your aqueous ammonia. So aqueous ammonia is only produced just by dissolving ammonia in the water molecule, right? So the rate of this ammonia dissolution in the water molecule is very, very high, so that the back suction can occur there. To avoid that back suction, we are just not doing anything else that we do in this HCl part, production of HCl part, liquid HCl acid. So the same thing we are producing here. You have ammonium chloride and calcium hydroxide placed in the round bottom slanted flask. Just provide heat to it. You just do nothing. Just on that tube you are providing an inverted funnel to it. You are using a inverted funnel for the passing of ammonia into the water, right? In the starting, when the ammonia is not produced till the time, then the pressure, when you just touch up this inverted funnel with the water molecule, what happened there? The pressure inside this pressure inside this funnel decreases, right? As the pressure decreases, the water molecules start moving into the funnel part, right? The water molecules ऊपर funnel के पास जाना start कर देंगे, and then on to the next moment, what happens when the water molecules are moving into the funnel? What happens to that? Just nothing, that the funnel जो है थोड़ा सा ऊपर हो जाएगा. जो funnel आपके पास में अभी यहाँ बिल्कुल उसके ऊपर present है, वो water molecule से जो उसका rim होगा वो थोड़ा सा upward ऊपर हो गया, ठीक है? बिकॉज अब उसमें वाटर फिल्ड अप हो गया था तो वो हैवी हो गया, तो थोड़ा सा वो क्या होगा आपके पास में अपवर्ड होगा. बट एज सुन एज द प्रोडक्शन ऑफ अमोनिया इज टेक्स प्लेस, जैसे ही अमोनिया का प्रोडक्शन होगा, अमोनिया गैस फ्लो करेगी तो गैस का प्रेशर अप्लाई होगा, राइट? तो जो हमारे पास में गैस है उस गैस ने अपना हाई प्रेशर को अप्लाई किया, एंड जो वाटर मॉलिक्यूल्स ऊपर इंक्लूड हुआ था वो वापस डाउनवर्ड इनटू द वाटर, और जो आपका फनल था वो वापस से क्या हो जाएगा, टच कर जाएगा वाटर के साथ में, और जो हमारी गैस है वो इजीली डायरेक्ट एक जो प्रेशर है वाटर के ऊपर अप्लाई करेगी. बैक सक्शन पॉसिबल नहीं होगा, राइट? टू अवॉइड करने के लिए बैक सक्शन को, इसीलिए ये इन्वर्टेड फनल को यूज किया जाता है. एक बार ये फिर से सुनिए. द वेरी फर्स्ट थिंग इज दैट स्टार्टिंग में जब गैस का प्रोडक्शन नहीं हुआ है, व्हेन देयर इज नो एनी गैस प्रोडक्शन देयर, देन जो आपका फनल है, दैट द प्रेशर इनसाइड दैट फनल विल डिक्रीज, and as soon as the pressure is decreasing, it means it's starting just picking up the water molecules into the funnel. The water molecules को वो filled up करेगा inside the funnel, and that water molecules will lift up the funnel. थोड़ा सा water से upper lift किया, but when the production of this ammonia molecules will start, that the production leads a pressure on the water molecules that is present in the funnel, and that pressure will just moving that water back into the water again, that water tub again. तो water वापस आ जाएगा and जो funnel का rim था वापस से touch करेगा हमारे water के साथ में, and जो directly अब क्या होगा, that ammonia gas is just passing into the water molecules. There is no such back suction will occur. तो कोई back suction वहाँ पे occur नहीं करेगा. So that is the methods where we are doing the preparations of ammonia and the aqueous ammonia, and the next part is preparation of ammonia with the help of the Haber process that we're going to study in the next lecture. Till then, take care.